calculus. This second video picks up with example 3. It's also finding the arc length. You'll notice straight away that this equation is not solved for x or y. We're actually going to solve it for x. I tried doing the problem earlier with the equation solved for y, and I found that when I was ready to integrating what was under the radical and things was quite difficult. So I think you'll find this one to be a lot easier if you solve it for x. Now when I solve it for x, I am going to be changing my bounds from 0 to 8. So what I'll need to do is set the equation equal to 0 first. So I'm plugging 0 in for x. I'll solve that and y will be 1. So one of my bounds will be 1. Then I'll plug the 8 in. Raise both sides to the 2/3 power, and y is 5. So now I'm using the bounds 1 to 5. Arc length will be the integration from c to d of the square root of 1 plus f prime of y squared dy. All right, going to start with the background work. What's going to go under the radical? So f prime of y is 3/2 y minus 1 to the 1/2. Second step, let's square that. I'm going to go ahead and multiply that out. Third step, let's add 1 to that. Now, I'm going to go ahead and factor out a 1/4. Taking the square root of that would be nice because I can take the square root of 1/4 and that kind of cleans it up just a little bit. That piece right here is what's going to go under the radical right here. Okay, I think we're ready to set up our integration. So we're going to go from now 1 to 5 of the square root of 1/4 9y minus 5 dy. The square root of 1/4 is 1/2. And we'll be using a little substitution here to integrate the 9y minus 5. So u is 9y minus 5. du is 9. So I'm going to have to pop in a 1/9. I'm going to write my integration all in terms of u. And when I do that, that will change my bounds. So I'm going to plug in the 1 and 5 right here for y, and that will switch my bounds to 4 and 40. I am ready to integrate. So 1/18 2/3 u to the 3/2 from 4 to 40. So 1/27, 40 to the 3/2 minus 4 to the 3/2, and that is roughly, let me just use my calculator here, 9.073. There's the length of the arc on the original curve from 0 to 8, or when it's solved for x from 1 to 5. The next video is going to pick up with the surface area of revolution. Before I stop this video though, let me show you the practice problems. The first 7 you're going to be able to do with arc length, and then the last 3 are surface area problems. So we're going to start there on the next video.